x to y f, there is a function g y to z, and there is a function h z to x. That is, from x to y there is a function, y to z there is a function, and z to s there is a function. This is f, this is g, this is h. Then h of g of f is equal to h o g of f. Both are same. There is a theorem. We will take an example to prove this. That is, h of, you take g of f first and then take h of this, or you take h o g and you take this. Both are same. We'll take one example to prove this. We have this function from n to n, f from g is also from n to n, and h is from n to r, where fx is equal to 2x, gy is equal to 3y plus 4, and hf is equal to sin z. We have to prove that hog is equal to hog of f. First take this part, let's take this part. This is nothing but h of g of f. This is nothing but h of g of fx. This is nothing but h of g of fx is nothing but 2x. G of 2x. This is nothing but h of g of 2x is nothing but 3 into 2x plus 4, because g of y is 3y plus 4. So this becomes h of 6x plus 4. 6x plus 4. H of 6x plus 4 is nothing but sine of 6x plus 4. Why? Because h of z is sine z. So h of g of f is sine of 6x plus 4. Now let me find the other one, h of g of f. This is nothing but h of g of fx. That is nothing but h of g of fx is nothing but 2x. This is nothing but h of g2x, and there is nothing but h of g2x is nothing but 3 into 2x plus 4, that is h of 6x plus 4, and this becomes sine of 6x plus 4. So if you see, LHS and RHS both are same. Thus we can say that h of g of f is equal to h of g. Both are same. We'll take one more theorem. This theorem says that if there is a function x to y, a function g y to z, and they are invertible function. Both are invertible function. X to y is a function f, and y to z is a function g. Both are invertible function. Then g of f is also invertible, and that is g of f inverse will be equal to f inverse of g inverse. This is the theorem. There are two functions, both are invertible function, x to y and y to z. Then g of f is also invertible. We'll take one example to do this. So there is a function f that has value from 1 to 3 to abc. So 1 to 3 are the value here, abc is here, and there is a function g from abc is apple, ball, cat. It's apple, ball, cat. F of 1 is a, f of 2 is b, f of 3 is c given. G of a is apple, g of b is ball, and g of c is cat. This is f and this is g. This is given. We have to show that f, g and g of f are invertible functions. So if you see, f function is invertible because if you see it's all 1 over 1. For any point ABC, if you see there's only one injection coming on. Also there is no off element in this one. ABC, there is no off element. So it is 1 over 1 and onto. So f is invertible. So we're talking about g. For g also if you see, G also, if you see, this A to apple, B to ball, C to cat, all these values are 1 over 1. Also, there is no often element here, so G is also invertible. If you view the whole picture GOF, what you will see, 1 gives apple, 2 gives ball, and 3 gives cat. This also, if you see, is invertible. Why? Because there is no often element here, and it's all 1 over 1 mapping. So all are invertible. First part is done. Second part is we have to find F inverse, G inverse, GOF inverse. All these we have to find. So if F is, so for F inverse, if you see F is 1 to A, 2 to B, and 3 to C. If you want to find F inverse, it will be just invert this. This will be instead of 1 to A, it will be A to 1. Instead of B to 1 to B, it will be B to 2, and 3 to C, it will be C to 3. This will be the map. This is my F inverse. Similarly, if I want to find G inverse will be same like this only. This and this will be apple, ball, then you have cat, you have A, B, C. You get this. Just flip it. You got F inverse, you got G inverse. You want to find what? GOF inverse. GOF, if you see, GOF is nothing but, see, GOF if you want, GOF is nothing but, you get 1 to 3, and here you get apple, ball. This is GOF. So GOF inverse I want to find. This will be nothing but from apple, ball, cat, I am going to 1, 2, 3. This is my GOF inverse. So I found F inverse, GOF, G inverse, and GOF inverse also. Now I have to prove that GOF inverse is equal to F inverse of G inverse. So GOF inverse is this. F inverse of G inverse, if I want to find, I have to merge these two. Correct? So what I have to do? I have to first take this guy, G inverse, that is this guy, apple, ball, cat, and this guy ABC. With this I have to merge this because it is F inverse of G inverse. So first I do G inverse and I put F inverse here. This is 1, 2, 3. If I merge these two, this is what I get, F inverse of G inverse. If you look this carefully, this is nothing but apple, ball, cat, and this points to 1. And if you see this, both the function are same. That is GOF inverse is equal to F inverse of G inverse. Both are same. Correct? So what we have done here, we have this function F, we have this function G, we found F inverse, we found G inverse, we also found GOF, and then we found GOF inverse. Then we were asked to prove F inverse of G inverse, we got this. This should be equal to GOF inverse, and we saw that both are